haven't tried this before either, but we seem to be recording.
Brian
Okay.
Miller says, is that no objection, or is that don't do it?
Yeah, be more specific, Brian, please. Okay to record. Thank you, Brian. All right, great. Okay, so at this point, I'd like to hand over to David to give a demonstration of some of the new features that we've been working on here at the team. David.
Do you want to swap mics so that I'm a little closer?
Yes, I will mute.
All right. Hey, hello everyone. I realize it's been a while since we had a big release. So I'm going to demonstrate a couple of the things that are being worked on that should be in that next release. Rest assured that we are working hard and we have a couple things to show off. So the two really big features that we've been working on are automatic generation of LaTeX tables for insertion in any papers that you might be writing. So there are a couple of built-in models that that you can generate those LaTeX tables for. As you may or may not be familiar, we have the concept of a target grouping, which is just a set of arbitrary targets that you collect because they make sense to group together, and the same for observations. So for either of those two groups, you can now generate a LaTeX table by specifying a few parameters from the model. And you can create this table of LaTeX with any number of fields and add your own headers and footers, along with functionality to just automatically copy that. Looks not like much. It was actually quite a bit of work. Hopefully that is something that people will find valuable. The other big feature that has been added is the concept of cadence strategies and observing strategies. Just to give a little bit of context, and please, Rachel, jump in if anything doesn't make sense. We've defined the concept of an observing strategy as just sort of a template for an observation. So you can see I have a couple of test strategies here. If we actually go and look at one, it just has a few fields that are filled out that I want to remain consistent for a number of observations. So this page allows you to just manage them. You can create a new one with any supported facilities, and that'll simply save that observation template with any target you so choose. You can then run an observing strategy. And then this other concept is something called a cadence strategy. So we have this concept of what we call reactive cadencing, which is when, based on feedback from previous observations, you trigger new observations or make other decisions. So we have a couple built-in cadence strategies and also the ability to customize your own cadence strategies. One in particular, the resume cadence after failure strategy, was based on our own SNEX project. Basically what this does is it waits to see if an observation has been completed or failed, and then it will immediately schedule a new one. And if, say, you have an observation every 3 days, it will then wait for the next or schedule the next observation 3 days later. So all this does is it brings you to a page that already has fields filled in for your template. It allows you to trigger a cadence with that observation. And I actually triggered one yesterday. It has a couple of observations. So what happened was I triggered one with a fairly large window that went from, I believe, the 11th to something like the first week of March. It triggered, I ran my cadence strategy, and it triggered the next one to have a window that started exactly 3 days later. And that one was actually scheduled. So a couple new features. These will be in the next release. Happy to hear any feedback that anyone has if they believe that there should be additional items or any questions. Is there anything you wanted to add, Rachel?
No, but I will give a bit more context.
Yeah, please.
No, I won't, because I'm still muted. Let me unmute that. Okay, now switch microphones. So to give a little more context, the reason we implemented these specific features was based on feedback that we got from our own scientists who are busy using the TOM Toolkit here at LCO, and some of us you can see maybe in the background have joined us for this meeting. And so both of these come from the features that have been put into TOMs that have been built for projects that are ongoing at LCO that are considered essential features by our team. So we find them useful, and we hope that you will too. And the Cadence strategy in particular, we implemented with a recognition that a lot of science strategies often have to do very similar observations of a wide range of targets, and what changes between each target is generally things like the exposure time because of the brightness of the target, or relatively small changes between the different observing groups. But you then apply that same strategy to a large number of targets. And that has been an extremely powerful thing to implement in different TOMs, because it makes the workflow of pressing go to submit a target observation much easier and much more fluid. And for that reason, it's been something that the Supernova team here at LCO especially has requested. A similar implementation has also been in use by the microlensing team. So we have implemented it in, we hope, a sufficiently general way that this could be easily adapted for any observing strategy. Likewise, the LaTeX table implementation was feedback partly from the transiting science area, which has long used programmatic generation of LaTeX tables to produce tables for publication. And so we're hoping to make that section easier as well and more smooth. Both of these features can be adapted, and they are designed in such a way that they will be easy to customize for your own science. So what's been implemented so far is really intended as a template, which will be available in the next release of the base toolkit. And if you want to customize it and adapt it for your own science, then please do so, and please feel free to ask questions on any of those topics. So I'm going to take a pause there for a second, because that was a huge amount of information, and thank you very much, David, for preparing that. Does anyone have any questions you want to raise at this point?
Right, I might say something. So as a facility provider, when we're looking at these Cadence features, you need to know when the last observation's been executed. So I'm just actually looking through what I've got, but we need to implement that in our facility in order to have that as a feature. Is that something that's required of facilities, or this is kind of an optional thing that will still look okay in the TOM Toolkit without?
So obviously something like this reactive cadencing isn't going to work if you don't have a way to update statuses. We can add functionality so that someone can update a status manually. So I wouldn't say that it's 100% required for it to work, really the way it's intended. Then yes, that would be important. But I wouldn't say that it's 100% required.
Okay, yeah. And so, yeah, I'm just opened it up. So yeah, we've got in the API the get observation status call. And the way that we would implement that is just whether the data has arrived in the data archive. Whereas I assume that your API to the LCO telescope network, you actually get some kind of hook of when the observation's been taken.
No, I mean, we just manually go and query for the status. So that is one thing about any of these strategies is we've implemented them with them to run with a management command, a Django management command. So ultimately, to take advantage of these features, everything's going to have to be set up with a cron job or some sort of scheduling mechanism to allow it to run automatically and periodically to ensure that everything's up to date.
Okay, so it's a polling situation in the LCO kind of functionality. Okay, yeah, that's good to know. All right, thanks.
Okay, any other questions what people want to raise at this point? Marcus, go ahead.
Well, is there a tentative estimate of the execution probability for a given execution window?
Execution probability would depend on the contention within the network, or rather the facility that you're submitting to, the weather, and so on. So it goes in as a regular observation. In that respect, it's no different. The only thing that, to a regular observation, the only thing that's different is how you're filling in the parameters of that observation. A lot of it essentially gets filled in for you so that it's easier and less workload on the user. Any other questions people want to raise at this point? Okay, so one last thing that has happened in the project that we wanted to tell you about in this meeting was plans for satellite tracking with the TOM Toolkit. Now, as a lot of you no doubt have heard, a large number of large commercial satellite constellations are under development. Most famous of these is of course, the Starlink constellation by SpaceX. But also there are a large number of others that are under development or have been registered with the authorities. These satellites are planned for relatively low orbits, normally LEO, and for that reason they're relatively bright by astronomical standards. They also have to be replaced on a regular basis, which means they will be launched very frequently, and that's going to be typically every 2 weeks for the foreseeable future in order to maintain the operational constellations. If all of the constellations that are currently being planned actually launch, the total number in satellites in lower orbits could rise to around 48,000 over the next 10 years. At this point, as you've no doubt heard, the concern is that they could seriously interfere with astronomical observations. So, in the short term, one way to help mitigate this issue on astronomy is to adapt our observing strategies to minimize or to avoid satellites intruding onto our data. And to this end, that we have started a collaboration with the team that developed Astriograph, and I'm going to put a link to Astriograph's system in the chat screen for the record. So they provide a service which compiles satellite tracking data from a wide range of sources and provides a public API. So this allows us to query their service for a given field of view, an RA and DEC and time window, and they will tell us what satellites are passing through the field of view within that range. We're planning to develop a TOM plugin for this so that you'll be able to query their service and find out what observations might interfere with any of your planned observations. And we're planning to develop visualization tools that will help you avoid satellite intrusion and try and mitigate or improve your planning process. So that's not yet in the current release. That is something that's very definitely in the development, but we wanted you to know that this is something that we're working on our end. So I will pause again for questions there because that proved to be a very contentious issue when we talked about it here at LCO. Okay, great.
There's just one, I mean, not really on the TOM side of things, but just this Astriograph in general. I mean, what's the data access rights? This is, you said this is open?
Yes, they are. They are committed to open data wherever possible. That means they have, I want to say, agreements with various providers of satellite information to make the satellite tracking information public. They, as I said, they harvest data from a number of sources, including a place called Celestrak, which is where most of the US satellite data come from. Obviously, not all satellite providers want to share that information, especially military ones. So this is not necessarily ever going to be a complete and comprehensive system, but it's possibly the best we have. And one thing that Astriograph is trying to develop that is different from some of the other services is that they are working with satellite providers to try and establish the brightness of all of these satellites as a function of time. And they are also planning an observing network to monitor the brightness of satellites as a function of time, which is obviously critical information if you're planning observations and you need to avoid them or know whether they're simply going to be too faint to worry about. Okay, so that was everything we wanted to tell you. So at this point, I want to throw out the conversation to you. And this is your chance to raise questions, tell us about features that you are personally working on or would like to see developed, or any comments that you have. At this point, usually people are super shy, so don't be afraid to speak up.
Got one question. I've seen a variety of pull requests related to non-sidereal target improvements. Maybe someone could just summarize what those are?
Yeah, so I've been helping out Wes Fraser, who's doing something related to that. So there's just a few things that were not terribly clear or not really well fleshed out or battle tested that he's noticing. There are smaller things like that we weren't pulling on all the target parameters from, or all the orbital elements from JPL horizons. Things like clearer indication of heliocentric versus barycentric. And then something I'm working with him on now is the ability to store a target as just a list of ephemerides. And so I think those are the only three, but yeah, it's generally in response to things that he's noticing as he's developing his TOM. And so it's really helping us to flesh out the non-sidereal areas of the TOM toolkit.
Okay, great, thanks.
Well, if you have any questions or comments that you want to reach us at any time, don't be afraid to use the Slack channel. And in future, we will organize one of these forum telecons. So if you want to discuss any particular item in detail, feel free to pose it to me and we'll include that in the next forum. In the meantime, thanks everybody for coming and we will see you next time.
Thank you. Bye.